Today we're going to be solving a problem from the film X plus Y, A Beautiful Young Mind. Let's dive straight into it. Okay, so this is the problem that was given in the film, and it says 20 random cards are placed in a row, all face down. A move consists of turning a face down card face up, and then turning over the card immediately to the right. Show that no matter what the choice of card to turn, this sequence of moves must terminate. Now I'm just going to start by illustrating this with a pack of cards. Now 20 cards is quite a lot of cards to show on screen, so I'm just going to be showing you 6 just to illustrate what this problem is about. So we have the 6 cards, and I'm going to choose a card at random. So we're going to choose this card. Now the card to its right is also face down, so we turn that face up. And again, I'm going to choose another random card that's face down, so we'll go for the end card, turn that face up. The card to its right is face down, so we'll turn that face up. Now we have the third card along is face down, so I'm going to turn that face up. The card next to it is face up, so that must be turned face down. Now we're going to do the same card again. We're going to say, okay, we'll turn this card face up. The card to its right is face up, so we return that to face down. And then we're just left with these 2 cards, and I'm going to say, okay, I'm going to turn this one face up, and therefore the card to the right is face down, so that one will face up. Okay, and the sequence there has terminated. Now there's a really nice trick to solving this, and it's what is actually used in the film itself. So let's have a look at the solution. So what we can say is we can start by saying, well, we're going to let a face down card, so let's say let a face down card, we're going to let that equal 1. Now we're going to let a face up card, let that equal 0. Okay, so draw something a little bit like this. So we're saying let a face down card equal 1, a face up card equals 0. So we know that in the problem we start with all of the cards face up. So let's say for a series of 6 cards we're going to have 1, 1, 1, 1, 1, 1. Okay, we'll say we know that all cards are down to begin with. Now, as an example, for 6 cards, we have 1, 1, 1, 1, 1, 1. Obviously, I'd do 20, but that would be quite a few ones. Now, what you'll notice is by labelling a card down as a 1 and a card up as a 0, we're essentially doing binary here. Now, the largest number in binary for, say, 20 cards would be all of the 20 digits being 1. So we have to begin with, the largest number is at the start, and that is because we have all of the 1s, all of the cards facing down, so we have all 1s. Now, we can say that from there are 3 types of moves. So I'm just going to say that this is for a 6 card example. And I'm just going to say this is binary. Now we can say we'll say there are 3 types of moves. Okay, so the first move we have is if we have both cards facing down and we're going to face them up. So let's realise that's the Joker card. So we can say that the first move would be move 2 face down cards face up. So that would be move 1, 1, 2, 0, 0. Okay. Now the other option would be to move a face down card. So we're always choosing face down cards, so we'll choose a face down card, and I've chosen the Joker again, but if the card immediately to its right is face up, then we're going to swap them around. So we're going to have move a 1, 0 to a 0, 1. Now the final move, and this is actually not permitted in this problem, and it's not something that's actually talked about in the film, and it's something that I'm going to omit from this video, but I'd love to know in the comments what you think, how you think things would change if this rule was actually still in here. So the final one would be to turn over the final card and then loop back around. And I'll just put and loop. But I'm just going to say, put a cross and say, we aren't allowing this. And like I said, I'd love to know what you think would happen if we did allow the card to loop. If your end card was face down, you flip that up, and then the card immediately to the right, you would loop back around and it would be the first card in the list, and that would then turn. So let me know in the comments what you think would happen then, but for the sake of the video, we're just omitting it for now. So essentially what's happening is, with the first two moves, and starting from a very large number in binary, so the all ones, when you then make your moves, essentially what's happening is you're always decreasing this binary number, and therefore eventually you are continually decreasing this sequence until it terminates. So if I just say, considering 1 and 2, the binary number is always decreasing and therefore must terminate. So this was a really, really nice question. It's got you thinking about a couple of different things. Obviously you think about it as probability to begin with because it's about cards, but it turns out to be a very neat example and a very neat solution as well. Now I'd love to know what your thoughts were on whether we were allowed that step 3, but also I have an additional question for you. What would happen, if anything, if we had an odd number of cards? Let me know in the comments, and I'll see you all in the next one.